The next example will be, let's say I have a language L1, set of all strings in which each string is divisible by 2. And in all the example we are bounded that the alphabet sigma is nothing but a comma b. Remember that sigma is nothing but a comma b. So language L1 is nothing but, if you take any particular string in this language, let's say W, and if you find the length of the string, the length of the string will be mod W, and if you divide with 2, mod 2, then the remainder will be 0. That means mod W mod 2 equal to 0. So how can I draw the DFA for such language? It is very simple. Let's say I have a initial state capital A. If I see a symbol A or B, then I will go to state capital B. Okay. Now if I see one more A or B, let's say if I see one more A or B, that means it is 2-length string, and this 2-length string is divisible by 2, then definitely C is the final state. But here question is, what will happen if the length is 2, 4, 6, 8, then all such length will be divisible by 2. So here you will simply take a loop on capital B. So if I see here small a or small b, then I will go to state capital A, and this is 1-length string and this is 2-length string. 2-length string will be divisible by 2. That means here length 0 is accepted, length 0 is epsilon, length 2 is accepted, length 2 is AA, AB, BA and BB. So what are the possible strings here? Epsilon, A, AB, BA, BB, and then 4 times A, 4 times B, 2 times A, 2 times B, and so on. Okay. So here 0-length string is accepted, 2-length string is accepted, 4-length string is accepted. How? One more, length 1, length 2, length 3, length 4. Okay, and here odd length string is accepted. Here even length string is accepted. Here odd length string is accepted. So I will make the state capital A as a final state for accepting in even length string. Okay, that's how you can draw the DFA for length which are divisible by 2. Now let's take another language L2, set of all strings in which the length of string, when we divide by 2, it will give a remainder as a 1. That means mod W, if I divide by 2, mod 2, the remainder will be 1. Can you draw this the DFA for language L2? It is very easy. Just take a slight modification in the above DFA. What you can do here is make capital B as a final state and capital A as a non-final state. What I mean to say, let's say capital A as an initial state, and if you see small a or small b, then you will go to a state capital B, and capital B represent that we will accept 1-length string, and 1-length string is not divisible by 2. It will give remainder 1. That means we can accept the capital B, we can take capital B as a final state and capital A as a non-final state. And after that, I will take one more length, capital A or capital B. I will go to the non-final state, capital A. If I take one more length, then means length 3 I will accept it, length 4 not accepted, length 5 accepted, length 6 not accepted. So that's how you can draw this. So here length will be 1, length A comma B will be accepted. Okay, one length string, and then after you can accept 3 length string AAB and so on. Okay, so can you generalize a formula for such type of language? When you divide any language, when you divide any strings in a language by, let's say, number n, let's say you divide mod w mod n, and if you get a remainder 0, then what is the total number of states possible in such type of language? Here the number of states possible is 2, and we divide it with by 2. So if you divide it with n, then the number of states possible will be n. Number of states is n. And what happen if you divide with, let's say, length n, and you will get a remainder 1, then the number of states possible will be also n. Okay, so for such type of languages, that number of states is exactly equal to the length of the string. Okay, in the next video we will see some other examples related to deterministic finite automata.